These are practice problems for lesson 8, translating to y equals mx plus b. And this is problem number 1. In this problem, you're supposed to select all the equations for graphs that have the same y-intercept. That means where they cross the y-axis in the same spot, in the same place. That is the second value here. That's the plus b part of the equation. So this is y equals mx plus b. The m part is the slope. So in each case here, for 1 unit of x, this graph will go up 3 units in the y direction. This graph also 3 units. This graph also 3 units. So these 3 graphs would be parallel to each other. They all increase for 1 unit change in the x value. They would increase 3 units in the y value. This one would go up at 5 units for that 1 unit change. This one would go up only 2 units, and this one would go up just a little bit, 1/3 of a unit for that unit change in x. Now these 4 all cross the y-axis at the same place at a -8. So I would change this to adding a -8. So that -8 will tell you that they cross the y-axis at y equals -8. So right here. So this is y equals -8. And so f has a slope of 1/3. So for 1 unit in x, that's this 1 unit down here in the pink. So 1 unit in x, it increases 1/3 of a unit along the y-axis. E increases 2 units along the y-axis. A increases 3 units along the y-axis. And D increases 5 units along the y-axis. So they get steeper as that value for the slope increases. The larger that number is, the steeper the graph is. Now B and C will be parallel to A. All 3 of them will have a slope of 3 units for every 1 unit in the x direction. But for B, it's going to cross the y-axis at -9. So this graph right here for A would be shifted down 1 unit. It would be parallel to A, so it would cross somewhere right down here at -9. And C would be parallel to A as well, but it would cross the y-axis 16 units above where it crosses here. So you have to go to 0, that's 8 units, and then another 8 units to +8, and that's where C would cross the y-axis, but it would be parallel to A because it has the same slope as A. This is problem number 2. And this problem is much like the 4th activity in the lesson, where you have 2 equations, and how are these equations the same and how are they different? So it's y equals 1/4 x. Then it's the same thing in the beginning, y equals 1/4 x, but then you're going to subtract 5. So what kind of graph results from both of these equations? How are these the same and how are these different? We'll start out with what you know. You know that y equals kx is one form of the equation. That's this one right here. You know that that forms a line, and you know that that line represents a situation that is proportional, meaning that both the x-coordinate and the y-coordinate can be multiplied by the same factor, and they will end up on that line. They will increase in the same way or decrease in the same way. So y equals 1/4 x, and it's going to cross the y-axis at 0. So you can add the 0 here. Y equals 1/4 x plus 0. So where x is 0, right here, y is also 0. So that line for this graph, for this equation, is going to cross right here. The y-intercept is right here at 0, 0. On the other hand, the equation on the right, same slope. So for 1 unit of x, the y unit is going to change 1/4 of x. That's the same for the first equation. But now this one's going to cross at y equals a -5. So I'm going to change this to subtracting a +5 to adding a -5. It's just easier to see that it crosses the y-axis at a -5. So the first equation on the left crosses the y-axis at 0, 0. The equation on the right crosses the y-axis at -5. So the lines have the same slope. Lines are parallel. So here are the lines for each one. So the line is drawn by going over 1 unit along the x-axis and 1/4 of a unit along the y-axis. 1 unit, 1/4, 1 unit, 1/4, 1 unit, 1/4. To get to this point right here, so you can draw the line, you know that you have to go over 4 units along the x-axis and 1 unit along the y-axis. So that's the 1/4 of slope. That puts that point on a grid line, the intersection of the grid lines. So you can place the point. This graph is parallel. So over 1 unit, up 1/4, 1 unit, 1/4, 1 unit, 1/4, 1 unit, 1/4. So these two lines are parallel. And notice for the second line, this line right here, you're starting at -5. So you're starting behind by 5 units along the y-axis. So to get to 0, where y equals 0, you have to make this part of the equation equal to +5. Because 5 minus 5 equals 0. So that would make y equal to 0. Well, this part of the equation right here, what makes that equal to 5? 1/4 of what number equals 5? Well, 1/4 of 20 equals 5, because 4 times 5 equals 20. So 1/4 of 20 is equal to 5, and then 5 minus 5 equals 0. So that means that you'd have to go out here 20 units, where x equals 20, in order to see this line right here cross the x-axis. So y would equal 0. You have to go way out here, where y would equal 0. It's going to be beyond the page. So that would make y equals 0. If x is 5, if x is 20, 1/4 of 20 is 5. 5 minus 5 is 0. So that would make y equal to 0. So this would be, this point way out here would be 20, 0. 20 along the x-axis, 0 along the y-axis. This is problem number 3. A cable company charges $70 per month for service. It says find a linear equation that represents this relationship. So find the equation for this relationship if x is the number of months and y is the amount of money that's paid in dollars. Now, a way to begin these kinds of problems is always to look for those two properties. The two properties in this case are money and the number of months. And what's the relationship? Is it money per months or is it months per money? Either one will work, but the way that they're giving it to you is it's money per month, $70 per month. So that is y over x. So y is the amount of money and x is the number of months. So y over x, and that's k, that is the constant of proportionality. So notice that in this case, y is 70 times the number of months, or the units of x. So if it's 1 month, it's 70 times 1 month. If it's 2 months, it's 70 times 2 months. If it's 3 months, it's 70 times 3 months. So y is 70 times the number of months. So y equals 70x, or 70 times x. And 70 is the constant of proportionality. That's the part that's repeating every time. It's whatever number of months it is times 70. So the cost is 70 times the number of months. So there's the equation, y equals 70x down here as well. So remember, that's y equals kx. That's a proportional relationship. It goes through 0, 0. So y is equal to 70x, or the cost is equal to 70 times the number of months. Then it says, what if new customers are charged $100 as a service fee to begin their service? It says repeat the previous problem using that condition. Well, now you start out owing $100 at the very beginning, and then you have to add to that how much money you owe for each month of service. So it's going to be y is equal to 70 times the number of months plus this $100 plus b plus the beginning amount. So a graph of that, this is the proportional relationship. So in 1 month, $70, 2 months, $140, 3 months, $210. But what if you start up here at $100? So it's this y equals mx plus b. This is an equation for a linear graph. It's a line, and it has a slope of m. M is what moves. It is not proportional. It does not go through 0, 0, because there's a beginning amount, and that's called the y-intercept. So it intercepts the y-axis at $100 because you have a $100 fee to begin with. So this is the second graph, the green line right here, and it intercepts the y-axis at 100, but every month it increases $70. So increases $70, goes another month, increases $70, goes another month, increases $70. So it has the same slope as the blue line, y equals 70x. It's just shifted up $100 or 100 units along the y-axis. So every point on this blue line is shifted up 100 units because you have to add that $100. So it's plus 100. It's plus 100 everywhere. It's going to be plus 100, but I'm just pointing out for each month that you're adding 100. So y is equal to 70x, has the same slope, plus $100, which is the amount of money that you begin with. And then it says, how are they related geometrically? And the graphs are parallel, and B is a translation of A, and it goes up 100 units. So it's a translation of the graph for A, and it's translated up 100 units. And both lines are parallel. So that's how it's related geometrically. Parallel, and it's a translation of A up 100 units. So this is problem number 4, in which you are given 4 graphs and 4 situations. And these are kind of fun to do. So one of the first things to do is to look at the graphs or the situations and to see if you can see a difference in each one of them. And where the difference shows up is the slope. So if you look at the situations for 1 through 4, each slope is different. Number 1 has a slope of 3. Number 2 has a slope of 1/4. Number 3 has a slope of 5/4. And number 4 has a slope of 2. So you can figure out which graph goes with which situation just based on the slope of the graphs. There's more information, such as where they cross the y-axis, or known as the y-intercept. That's just going to help you confirm your answers. And so A crosses the y-intercept at positive 8. So this is going to be y equals mx plus b, and that b is going to be a positive 8. B is going to be positive 3, so y equals mx plus a positive 3. C is a proportional relationship, so this is y equals kx, goes through 0, 0, and D likewise is a proportional relationship, so y equals kx. There's no b, you're not adding anything along the y-axis for C or D. So let's look at A first. It crosses the y-intercept at positive 8. And then if you look at the slope for, actually if you look at a horizontal change of just 1 unit, this is too hard to tell where this is for the vertical change. So what you want to do is follow the line and go to a point where the line crosses an intersection of the grid of the graph, which is right here. And so if you go out to that point, that is a change of 4 units along the horizontal axis and a vertical change of 1 unit. So that is a slope of 1/4. So once again, the horizontal change is 4, the vertical change is 1. Horizontal change is 4, the vertical change is 1. Horizontal change out here would be 4, and that vertical change would be right up here would be 1. So now just look at the situations. Which one has a slope of 1/4? And that's number 2. So the amount of money Y in a cash box after 8 tickets are purchased for carnival games. So the slope of the line is 1/4. So it looks like it's 25 cents per ticket. But then what does the plus 8 mean? It means that there was $8 in the cash box before you started selling tickets. So 1/4 times the number of tickets sold is going to be the money that you take in for selling those tickets. And then you have to add the $8 that were in the cash box to begin with. And that $8 is there to make change as you sell tickets. All right, so graph B. What's the slope for graph B? Well, the horizontal change is 1, the vertical change is 2. And you can see that easily on the graph. So the vertical change is 2, horizontal change is 1, 2 over 1 is equal to 2. And notice that this begins at a positive 3. So which situation has a slope of 2? And is there more information in that situation about possibly beginning at positive 3? And the situation that has a slope of 2 is number 4. It says the graph shows the cost in dollars y of a muffin delivery and the number of muffins x ordered. So each muffin costs how much? Well, each muffin costs $2. So by one muffin it costs you $2. By another muffin it costs you $2. Another muffin it costs you $2. So it's $2 times the number of muffins. And then what's the $3? Well, the $3 is the delivery fee. It doesn't really tell you that in the situation, but it does say there's a muffin delivery. So that $3 is the delivery fee. The third, or graph C, so if you go 1 unit along the x-axis, how many units along the y-axis? It's 3 units along the y-axis. So that slope is 3 units along the y-axis for every 1 unit along the x-axis. So 3 over 1 equals a slope of 3. And where does it cross the y-axis? At 0. So this is a proportional relationship. So if you go out here to 3 and up to the value for y, it's 9. So the x value is 3, the y value is 9. So now if you double the 3 to 6, so if you go out here to 6, then you're going to double y, which is 9, to 18. So this is going to be 10, 11, 12, 13, 14, 15, 16, 17, 18. And that's what a proportional relationship means. Whatever factor you multiply the x value by, in this case 2 times 3 is 6, the y coordinate is also going to be multiplied by that same factor. So 2 times 9 is 18. So which situation has a slope of 3 and basically has no beginning part? The beginning is 0. And that is situation number 1. So the slope is 3. This is the perimeter of an equilateral triangle. An equilateral triangle has 3 equal sides. So the perimeter is 3 times the length of one side. So whatever the length is of one side, it's 3 times that to get the perimeter. And notice if you have 0 length of a side, you don't have a triangle. You have 0 perimeter. So it goes through 0, 0. It is a proportional relationship. And graph D, this is another case where you go out 1 unit along the x-axis. This isn't very convenient. It's pretty hard to tell where that point is on the y-axis. So if you follow this line to where it intersects the grid lines, both the vertical and both the horizontal and vertical grid lines, then you can tell what that point is. So the horizontal change out to here is 4 units, and the vertical change is 5 units. So the slope is, for every 5 units, it changes 4 units in the horizontal direction, so the slope is 5/4. So it's 5 units in the vertical direction, 4 units in the horizontal direction. And the vertical intercept is 0. So which of these situations, it's got to be the last situation, has a slope of 5/4? It's this one right here. The number of chapters read, y, after x number of days. The slope of the line is 5/4. So that means that this person is reading more than 1 chapter a day. They're actually reading 1 chapter plus 1/4 of a chapter. So this equation is y equals 5/4 x. They're reading, and when they start figuring that out, they haven't read anything in the book yet. So they're reading 1 chapter plus 1/4 of a chapter each day, which is 5/4 of a chapter. 2 days, it's going to be 10/4. 3 days, it's going to be 15/4, and so on. This is problem number 5. In problem number 5, it says a mountain road is 5 miles long, gains elevation. It's the number of feet that it's going up above sea level. It gains elevation at a constant rate. After 2 miles, the elevation of traveling on the road, the elevation is 5,500 feet above sea level. After 4 miles, the elevation is 6,200 feet above sea level. So what does a little drawing of that look like? So after 2 miles, the road is 5,500 feet above sea level. So this y-axis, it would be feet above sea level. And the x-axis would be number of miles. After 4 miles, it goes up another, and we're going to figure this out, but it's 700 feet. It goes up another 700 feet to an elevation of 6,200 feet. It says find the elevation of the road at the point where the road begins. So you can figure out this change. So after 2 miles, it's a change of 2 miles. And how much does the elevation change? It changes 700 feet. 6,200 minus 5,500 is 700 feet. Well, if it goes up 700 feet in 2 miles, you have to just go backwards 700 feet, or you have to go down 700 feet to get to where it begins. So that's going to be 5,500 minus this 700 feet to go back to here at the starting point. So, and that's going to end up at 4,800 feet. So the road starts at 4,800 feet at an elevation of 4,800 feet, and it goes 5 miles out, and it increases how many feet per mile? Well, that's 700 feet divided by the 2 miles. So it increases 350 feet every mile. So it goes 1 mile, goes up 350 feet, another mile up 350 feet, another mile up 350 feet, and another mile up 350 feet. So let's put together a little table and just complete this table, what it looks like. And it's 5,500 feet to 6,200 feet. That's an increase of 2 miles. So that's the change in x. What is the horizontal change? So the number of miles traveled along the x-axis is 2 miles. And what's the vertical change that goes with that? That is 700 feet. So then if you go backwards, if you subtract the 2 miles, and you go back to 0 miles, which is where it crosses the y-axis, then you subtract 700 feet to go back to 4,800 feet. And I wrote the equation here. It says, describe what you see at point, see the point in part A on the graph where y represents the elevation in feet and x represents the distance along the road in miles. So that's the equation. So what's the equation? Describe where you would see the point in part A on a graph where y represents the elevation in feet and x represents the distance the road in miles. And so this is the equation for that. And you'd see this point at 4,800 feet. All right, so to write that equation, you can call this point right here x and y. So now we know the slope. The slope is 350 feet. So that's the right side of the equation. To write the left side with the x's and the y's, we're going to call this point right here x, y. So this point, to get to that point, you start on the x-axis, and how far do you go up before you actually start drawing the slope triangle right here? Well, you go to 5,500 feet. So that's the starting point, and where you end is at y. So what's this length right here? It is y, whatever that distance is right there, whatever that point is right there, minus 5,500 feet. So that's y minus 5,500 feet. You can look at it this way, y minus, and this point right here is 5,500. So y minus that 5,500 feet, and where x starts is at 2 miles, and it ends at x. So it goes out here, and remember this is x, and this is x as well. It's going the same distance from the y-axis, whether it's this point here or this point here. So you go to 2 miles, and then you end at x. So to figure out that horizontal change, you have to take where you end and subtract from that where you start. Start at 2 miles, so this is x minus 2. So it's y minus 5,500 over x minus 2. Well, that's the vertical change over the horizontal change, which is the slope. We already know that. that is 350 feet. So now you just work through this equation that's telling you that y minus 5,500 is 350 times whatever this horizontal change is. Well, 350 times that horizontal change is right here. And then you can, if you have 350 times x minus 2, that tells you you have 350 x's minus 350 times 2, which is that 700. So remember, we subtracted that 700 right here a while ago. So that's 350x minus 700, and that's equal to y minus 5,500. So we're just working with this side, and we say that it's 350 times this side, or this amount here, so then we can move this amount over here to complete that multiplication. And then if you subtracted 550 as the starting point, and that's, remember, that's sliding as if this is a sloped triangle that slides down here 5,550 feet, and it slides over here 2 miles to get to the origin right there. So if you subtract the 5,550 feet, you have to add that back to get to this point right here, to get the coordinates of that point. And at the same time, you have to subtract 700. Well, if you add 5,500, subtract 700, you end up at 4,800. So the equation then is y equals 350x plus 4,800. So for each value of x, let's say that x is 4 miles, to get this coordinate of this point, the y coordinate of this point, you have to plug in 4 times 350 and then add 4,800 to that. You do that, you're going to get an answer of 6,200. So this coordinate right here is going to be 4 miles on the x-axis and 6,200 feet of elevation, that's along the y-axis.